to see this example because it shows what you are going to do when you use Notepad++. So here is Notepad++ in full glory with all these nice widgets that you have here. And then what I have inside is a little factorial function that we used last time. So factorial of n is defined if n is less than 2, return 1, otherwise return n times factorial of n minus 1. So this is definition of function between def and end, factorial of argument n. So what I want to do, I want to compute factorial of 5, of 0, of 5, and 10. So what I want to get is 0 factorial is 1, 5 factorial is 120, and 10 factorial is this value, 3 million. So what I want to have is printing of this on the output. And when I generate output after pressing F6. So if you work with Notepad++, you have this in one window. Then you click functional key F6 or press, not click, press F6, and this opens a new window where you have a command that is executed. And then in that window, you get the results. Okay, so how to make these results, how to print that? There are two commands that are used, print and put string. All of them I have in this for loop. So you say here for the first time an array. An array consists of these three components, 0, 5, and 10. And then for n in this array, so n is first 0, then n is 5, then n is 10. So this is loop for n in this set, if you want, or in this array, perform this operation, and 4 has at the end end, same as definition that has end. So what we are going to do inside is to first use print statement and then put string. So what is print? Print is statement that is taken from C. So you have first that I display n, and then after that I display exclamation point equals. So 5, this is going to be factorial equals, and after that I display factorial. And this is what print statement is doing, just is making side effects. And then we are putting one new line so that the next value will be printed in the next line. Now, print is not automatically adding a new line. So it is not print line, but it is print. On the other hand, put string is automatically adding new line at the end. So if I do the same thing using put string, then I have here string that starts with double quote and terminates with double quote. And inside I have here exclamation point and equal. However, I want to embed in this string n and factorial of n. So if you have an expression that you want to insert inside the string, you have to put pound sign and these two brackets that you have. So pound sign is here, and you have two braces. Sorry, braces, not brackets. So you have two braces, and inside you put the value that is going to be real or integer or whatever else. And this is going to be converted and inserted inside this string that is displayed with put string command. So I have here equals, and then again factorial is going to be evaluated and then converted to string and inserted here. So you get 5 factorial equals, and then 120, and then new line. And this is done by this put string. You can do that also explicitly by saying n, this is an object, and then this dot is separator between object and method. So method is convert to string. So if I have this object dot method convert to string, it is going to create the string that is equal to this value n. For example, where n is 10, you are going to create string 10. Then this string 10 is going to be concatenated. So this is concatenation, concatenation with the string exclamation point equals, and then concatenation with factorial of n converted to string. Now, one thing that you see here is an object, which is in this case an integer, dot method. Method is conversion to string. Now, this dot here tells you something about syntax of real numbers. So if you say not n, but put here, for example, 5, and put a dot after 5, so 5 with dot is something that people might expect that it is a real number. It is not a real number because this is object-oriented language, and dot is used to separate object and method. So method applied to this object is an object dot method. So if you say, if you put here 5 dot, then Ruby is thinking, okay, 5 is an object. Now give me the method that is going to be applied to that object. And if you put nothing here, this is going to create an error and will say, hey, give me the method. Method is missing. However, if you want to put 5 as a real number, then say 5.0. And then Ruby will understand that this is the real number because after dot comes part of real number, and then that is perfectly okay. But no 5 with dot, because you always expect methods to be after dot. And of course, you can have multiple dots. You can say object dot method, this returns another object. Then dot method returns another. So you can say array, and then sort, and then convert to string, and then display, for example. So all these things can come one after the other in the non-procedural form of programming. So any question about this? What comes as the result? I have this print statement. All three of them are the same. They show the same thing. 0 factorial, 5 factorial, 10 factorial, exactly the same, except that they are written in these different ways. You are going to see this print and put string everywhere around. If you just need new line, you can say put string without anything here, and then this is going to give you a new line only. A few words about ranges. There is inclusive range, for example, from 1 through 5, to create sequence 1, 2, 3, 4, 5. And this is what we had in Pascal to some extent, because Pascal introduced these 2 dots for range from initial integer value to final. So 1 through 5, this range can be then processed. This is an object that is a range. So this object can be converted to array. So 1 through 5 converted to array. So 2a means return this, convert this object to array. And you get array of digits 1, 2, 3, 4, 5. Array is written with commas. So it is similar to scheme, but no spaces here, but commas. Commas are separators. So this is inclusive range. You can have also exclusive range, a range that is not taking into account the last value. So 1, 3.5 is going to be sequenced from 1 to 4. So you can say from 0 to n, that is 0, 1, 2, 3, up to n minus 1. So this is range without the last value. Also, all languages that have sets need to have a membership method. Is an object inside a collection of objects. So do you have a set belonging or not? How to do that? Well, set belonging that is written as this E mathematically is not available on all keyboards, and therefore you have to use some other symbol. And there are practically two possibilities. The first one is to use the word in, like in Pascal. So you say this object is in this set, which returns true or false. And the other way is to use something else. And Matsumoto decided to put three equality signs, which is belonging to set. So if you say, I have here this object, which is range from 1 through 5, and then whether 5 belongs to that object. This returns true. But if you say if 1, 2, 3, 4 is the range, then 5 is not belonging to that range and returns false. So you have to put range and then object, not object range like in mathematics. So first comes range and then object. You cannot put object equals range. This is not going to work. So range equals range includes object. So you can pronounce this as includes. So range includes object, can be true or false. There are also global constants that are not all of them implemented in 272 the way it is written in the reader. In the reader, you have the word platform here, and platform is telling you what is the platform on which you work, or release date. Where is the release date of this Ruby? Of course, this release date should be written in this way with Ruby prefix. So you cannot write release date only, you have to say Ruby and put release date. Ruby platform release and Ruby version. So you cannot say only version. So this is not going to work on 272. These are small cosmetic differences, but we have to take them seriously into account. I have to make 30 seconds of break. Just a second. Sorry, folks, for this break. I had to turn off heating. Heating is so terribly strong that it is going to burn here. Okay. Now it is okay. You hear me? Hopefully everything works.
I can hear you.
Okay, thank you. So the only thing that is different that you have to put here, this Ruby, Ruby, Ruby. Otherwise, there is platform release date and version. I did this, corrected this slide yesterday, and says that this release date was October 1st, 2020. That's the Ruby that we are using here, this 272, and this is going to change, of course. Argument vector and environmental vector do exist. And then you have standard in, standard out, true, false, and nil. Nil is interesting because nil is a global constant that is used to determine object without value. So it is an object that has no value. And if you print something, since print command, like this one here, is only doing side effects. It is printing n and equal and factorial. Then when we do this, we have that the result is going to be a printed string, but also this is going to return the value. So you're going to get, after printing, the nil as the result. And let me show you here another screen, just a second. I think I have it still on the screen. Here, this one. Okay. So this is in very tiny letters, but I suppose you can see it. So what I have here is an array A that has 1, 2, 77, 4, 7, 7. That's the array. So if I want to print array, I get array printed, but after that it is returning nil. If I say put string array, I get 1, 2, 77, 4, 7, 7. These are components of array, and then returns nil. So this is functional programming. Each expression has to return a value. So if you say put string A, convert it to string, A is an array, convert it to string, you get this string, which is array 1, 2, 7, 4, 7, 7. So this is the, and after that, the returned value is nil. So the put string and print are returning the value, and this value is always nil. If you have, for example, put string 1, 2, 3, 4, you cannot do that because there are more than one object. You have to convert this to string. But if you, so this creates an error. But if you have put string 1234 as an integer, you get this value, which is a side effect. This is the side effect. And then you have the value that is returned, and this is nil. So all these prints and everything else returns the value. And if the value is empty, then we return an empty object. And this empty object is this empty object is the string. So is nil, not string. So there's nil here. Okay, so that's the meaning of nil. You are going to have it in many cases where you have nothing to put in an object. Variables are identifiers of objects, same as in scheme. We have that they identify an object holds the value. And variables are not declared and not statically typed. So if I have variable A or X, it is not clear what is the data type, and you don't have to declare them. Variables are declared and typed at the moment of assignment, when you assign the value. So this is called dynamic typing or duck typing, okay? So the value is determined at the moment of assignment, which means at run time. So if I have interactive Ruby and I say binary value is 11111111, so I have 8 ones. So 0B tells Ruby that what comes now is a binary number. Then to put 8 ones, I have here one continuation. 4 plus 4 is 8, and the value of this is 255. This is 8 ones. You can also write that as octal number. Octal is 0. Prefix 0 says this is octal number. 377 is again, this is 377. It is the binary content, which is equivalent to 255. Or in hexadecimal, you can say 0x, lowercase or uppercase works the same, FF, which is F and F, these two binary values. So binary, octal, hexadecimal are defined as integers that have the value 255. Normally, we write decimal numbers, so decimal 255 is this here. So why we have that 255 is returned? I am just assigning the value. Because assignment is an expression. Everything is an expression, and expressions return the value. And this is something that supports functional programming. Therefore, if the language supports functional programming, all expressions have to return value. Therefore, this is what is returned from this expression. And then if I ask, is binary plus octal plus hexadecimal, which is 3 times 255 equal to 3 times decimal, the answer is true. Now this here is an expression, and this is the returned value. But this here is also an expression, and this is the returned value. So this happens in all cases when we have functional languages. Functional language always has expressions that return value. Variables are classified into these 5 categories. First, we have local variable, which must be written in lowercase, like this name here. Then this is the variable that is created and instantiated in the middle of execution. Must begin with lowercase letter or with underscore. If you have objects, objects consist of the set of instance variables. So if you have that something is an instance variable, it must be written with the prefix at. So name with prefix at is reserved for instance variables, so belongs to an instance of a class, and you can read this only if you are a member of the class. If you are not a member of the class, if you come from outside, you have to use an accessor method if you want to access instance variable. So instance variable is accessed using an accessor method. And there are also class variables that are shared among all instances of a class. They are written with 2 at signs. So this is beautiful that with the name of variable, you immediately see the role of variable. The role can be local variable, instance variable, class variable, or if it starts with $, it is a global variable. So it is available in the whole program. Global value of program has dollar as the prefix. Therefore, this is going to be available in the whole program. Sometimes there is a need to have named constant. For example, if you have an array that has a size, you may want to have size written. Size is 1,000. So you have an array that has 1,000 components. And if you want to have named constant, it must start with uppercase. Usually, the style is to put all this in uppercase. So size will be written in uppercase or const in uppercase. So this is named constant. So this is the syntax. Local variable, instance variable, class variable, or named constant. So when you see the name of it, you know immediately what is the role of this variable, which is very, very nice feature. Ruby supports parallel assignment. So things that happen in parallel. So ABC is 1, 2, 3. That means A equals 1, B equals 2, C equals 3. So first component is going to first variable, second to second, third to third. If you say AB is 1, 2, 3, then 1 is going to A, 2 is going to B, and 3 is ignored. Nobody uses that. But if you say ABC is 1, 2, then of course A is going to be 1, B is going to be 2. How about C? Poor C has nothing to obtain here. So it is going to be assigned the value nil. Nil means this is an empty object. So C is an object that is instantiated with nil. That means at this moment has only name, but no any other properties that would be more specific. So it is an empty object. Now comes the most beautiful thing, swap. AB is BA. Since all these operations are obviously buffered, so you go from 1 to buffer and then from buffer to A, from 2 to buffer, from buffer to B. So you can say AB is BA. So this is the swap operation. And we have parallel assignment that has 2 operations. A is B and B is A, done in parallel. Of course, this is not going to go directly, but it's going to go through a buffer that is not visible here. And therefore, there is no need to have temporary value. temporary equals A equals B equals temporary. This is how we do swap in procedural languages. But here we have parallel assignment, and this is beautiful thing that you can write AB is BA, and this performs swap. So we have here examples of ABC is 1, 2, 3, and then I have here print statement. A is A, B is B, C is C. So you have A is 1, B is 2, C is 3. That's what is returned. The only thing that I have to mention is that here are parentheses. But when we were printing here a minute ago, there were no parentheses here. I print this without parentheses. And this tells you one thing, that parentheses are optional. So print is a function. And these here are arguments of that function. However, in Ruby, you can say this is operator, and this is operand, 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 operand. So operator going to operands is what? Exactly the same interpretation as its scheme. So there is no need to put parentheses. You can put them optional if you like them, or you can remove them. Functions will work the same way as in functional programming, where you have operator, and then operand, 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 operator is applied to all pairs of operands. Okay, so here I decided to put parentheses to show that, and this works the same way as without parentheses. So A is 1, B is 2, C is 3. If you say AB is 5, 4, blah, 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 then I get 5, 4. If I say ABC is 1, 2, then this C, poor guy, is nil, doesn't have any value. If I want to swap AB is BA, so AB is 1, 2. After I swap this, I have that 1, 2 becomes 2, 1. They are swapped. Block expressions, same as in scheme, when you have begin, expression, 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 and then you return the value of the last expression. Ruby has begin end as a block expression. Block expression means this is the beginning of the sequence, and then you have here gazillion statements that you can put in that body, any number of statements. And the last statement that is executed will be returned by the block. So the block expression returns a value. This block will return the value. And the value is always same as scheme, the value of the last expression executed. So this expression n. Why is that useful? Well, because in functional programming, sequence is an expression that returns a value, and therefore value is the last executed expression. Why the last one? Because it is assumed that we are computing things to create the result. So the computation is performed in 90% of cases, not only for side effects, but for returning some result. And this result can be input argument in another expression. So it has to return a value. So between begin and end, you have operations that at the end should return a value. And this value should be inserted now in other expressions or printed or used in any way, or not used if you don't want to use it. But it is going to generate the value, which is the last expression that is executed. Now, Ruby has control structures as any other language. So Ruby offers a rather wide spectrum of control structures, including standard selections, loops, jumps, and other things. And the first surprise that you are going to have with Ruby is support for procedural programming. Control structures are what? This is the basic support for procedural programming. That's how procedural programming is done. Well, you are going to be surprised to find that Ruby introduces some unknown new versions of iterators, array generating loops, and something that is big contribution to procedural programming. And total number of Ruby control mechanisms is approximately 30. So this is something that is visible in this slide that has the list of control structures that are available in Ruby. So Ruby is obviously having the goal to give best possible support to procedural programming. And it has also fantastic support to object-oriented programming and equally fantastic support to functional programming. So Ruby supports procedural programming very much. And here is the proof for that. You have plenty of conditional statements. So if then, if else, if else, unless else, if unless modifiers, case with condition, case with selector. So all these various conditional statements are more than what you can find in C, C++, or Java. C is procedural language, but it has if, then, and nothing else. And then you put inside and switch case. That's all what it has. So switch case is one of this, and if, then else is one of these ifs, and these others do not exist. So here you are going to have luxury of having more of them. Then with loops and iterators. Loop do is infinite loop. While do is loop with the exit at the top. Until do, loop with the exit at the bottom. While until can be used as modifiers appended at the end of an expression. Then for loop, that is for element in collection, do something. So you can have loop going through the elements of a set. So through set elements or through elements of an array or any enumerable object. So for an in object that has components, so you can go through all components. Up to, down to iteration, same as in Pascal. Times, loop with explicit counter, like in COBOL. Then each which index. That's a fantastic mechanism because you can have a collection of objects. So object that belong and create a collection. Then each is going to extract one object from that collection and give you possibility to process that object. This is each. And then after the object is processed, it is going to be tagged internally that you don't see that it is processed. So when you continue with each statement, it is going to take another object from this collection of objects and so on and so forth. And you can do that with counting or not, but it is going to take this object one by one and will tag them internally. So you can say for employee in department, do something like in SQL. So for employee in department, that means take one employee in the list of employees and then tag that it is processed so that you don't process it twice. Then comes map. Map is literally, brutally stolen from scheme. Works same as in scheme and has a name same as in scheme. Take a method and map it to collection of objects. Apply method to first, second, third to all objects and get collection of processed objects. So that's map same as map in scheme. Step stolen from Fortran and BASIC from last century. So you can have real numbers that go with steps, 0.1, and create a loop with step. All these iterators are available. Compare that with any language that you know, and you will see that you have more here than in other languages, particularly procedural languages. Then you have here very frequently the situation where we have to process components of array. So this is a loop that is going through components of array with some condition that is hidden inside. Collect, select, reject, inject. You have none of them in procedural languages. And this is something that is very frequently used. Collect, select, reject, and inject. You process the loop by doing some operations with components. So either those that satisfy condition or you reject those that satisfy condition, or you select all of them, or you inject. So jumps, exit and quit are two of them. Modifiers of control flow. Return, break, next, redo, retry, throws, catch, and rise, rescue. All these are modifiers of control flow. This is the most rich combination of them. Of course, break and next you have in procedural languages. This is break in C or continue in the loop. This, but you don't have redo, you don't have retry, and all these other things: throw, catch, rise, rescue. Conditional statements, same as in C, ternary operator. You can have piece of code that you want to be executed before a program runs. Do something preparation with files or something. So you say begin with uppercase, and this is going to be executed before programs run, and means do something at the end after program terminates. So you can have begin and end that have something that is executed for and after. So this is very rich set of control structures that gives you all possible capabilities for procedural programming, for a very easy with high expressive power procedural programming. Now, let us start to study them. If then, if is written as an expression and returns value. All of them here return value. Some of them return a specific value, some of them return the last statement, some of them are returning nil, but they always return the value, same as in scheme. So if starts with if and terminates with and returns a value. This is an expression. So if x equals y, then make side effect, put string x equals y. So if x is y, display this, and then what is going to be returned? Well, there are only side effects, so it is going to return nil. But if you put something else inside, it is going to return the value. Basic relational operators are same as C, C++, and Java. You have equal, not equal to, greater than or equal to, less than, or equal to. Logic operators, there are two of them, and or not, and or not. But this here comes at high priority level, and this here comes at low priority level. So they are same, but you have precedence than this two. So you can write and or not if you want, or and or not, but pay attention about precedence. If statement can be used as statement modifier. This is something completely new for you, I guess, because you can have a statement that is conditionally executed. You can say put string x equals y, but do that if and only if x is equal y. So when you say perform this, if this condition is satisfied. So it is if statement using if as modifier. So if x equals y can be true or false. And if this returns true, then you are going to execute this statement. If this is false, you are just going to drop down without executing this statement. So this is called modifier. Modifier is modifier of a statement. So this statement has here a permission to be executed. So write x equals y if and only if x is equal y, or if this here gives you permission and this permission is true. Therefore, if x is equal y. So this is something that is new, using control structure as modifier. You can use all of them as modifiers. Not surprisingly, all logic expressions have short circuit evaluation, which means if you say A and B, this is internally executed. If A is false, then return A and stop execution of this. Else, return B. So if A is false, you are never going to execute B. If A is true in OR statement, you are going to return A and will never execute B. So it is short-circuited. B is executed only if A is not true. So we try to see whether B is true. Here is an example. I have ABC is 1, 2, 3, and then say if A is less than B and B is less than C, then put string A is less than B less than C. So here is A is less than B less than C. You can also use here not this end, but word end. if A is less than B and B is less than C, then put this string A less than B less than C, this here actually. Or you can use it as modifier. You can say print A is less than equal to B less than equal to C if as A is less than equal to B and B is less than equal to C. So you have that this is going to be displayed if this condition is satisfied. So you don't have to put this, but you can put this in shorter form as this. This is also something that you can use in scalar sort. So if I say AC is CA, A, B, C is 1, 2, 3. If I swap A, C, and CA, then I'm going to get 3, 2, 1. So I have that A, B, C are 3, 2, 1 here. Now, I can make the sort. If A is greater than B, then AB is BA. If B is greater than C, then BC is CB. And now we have that C is the largest value. And then we go back and check whether A is greater than B, swap them in that case. And now we have scalar bubble sort. This is bubble sort with scalar values. And then print A is A, B is B, C is C, and you get 1, 2, 3 sorted values. Syntax of if statement. Well, if statement has very rich sequence, very rich set of options. So we have if, this is the beginning of each statement, and at the end. So this is left parenthesis and right parenthesis of if statement. You have here Boolean expression. Boolean expression can be true or false. So if Boolean expression is true, you are going to execute this body. If Boolean expression is false, you are going to do next condition. So if Boolean expression is true, then two things can happen. The first one is that you have this then or colon. Now, these brackets are used as in extended BNF notation in BNF for optional elements. So this then and or colon are optional. You can omit them. And most frequently people omit them. Why? Because the limiter between Boolean expression and body is this end of line that stays somewhere here. So end of line is used for delimiter, and therefore you don't need to have the keyword then. But if you put everything in a single line, then is necessary because it is the limiter between expression and body. Now, in older versions of Ruby, particularly 1.8, it was possible to be lazy and instead of this then put colon. This colon was a little too much, and then Ruby decided not to support that anymore. And currently, colon is not supported. I put that in the reader because if you buy some older book, if it is used book and you buy it for nothing, and I very much suggest that you can find this column inside. Don't be afraid of it. It is no longer working, but it is available in older Ruby literature, and no problem with that. It was used for replacing a word then and word do in loops. So it is not longer supported, but I put it in the reader to tell you that this used to be an option. And of course, all this can be omitted. Then, if Boolean expression is not satisfied, we are going to go to next Boolean expression. And this is else if. Pay attention that this is not like in C or C++ else if. That means an if statement inside else and another if statement inside else. It is if else if else. Therefore, it is written as else if, else without E inside, else if as a single word. So if else if another Boolean expression, else if, else if, else if, else if, any number of them. So this is optional from here to here. You can omit it or you can use it. If you use it, you can have then or not have then, and it is going to work the same way. And here you can have any number of statements in the body. You can have first, second, third, etc. You can have plenty of components in this body. Else, if all these conditions, Boolean conditions, are not satisfied, you are going to execute the body, and body is here after else. So else and end are delimiters for the body of this if statement. So if and end come at the end. Now, example how this can be written. It can be written to make skip function or even else branch function. So you can say if condition, then be end. So if condition is satisfied, then perform be end. You can also say be if condition. So this one here, be if condition. If is now the modifier. Perform body if condition. This here is equivalent but no longer supported. Used to be supported up to version 1.8. You can write if C be end without then, because then is optional, used in a single line. So if C be end. Of course, this B can have 2000 statements and therefore is not written in the same line, and you put it here. Wherever you have if, at the end, there is end. So if C, perform block 1, else perform block 2, end. And this is how the if statement should be written. So keyword then is optional. If condition then block end, you have to put it because it is in a single line. And then if you remove this end, it is not clear where is the end of condition and where is the beginning of block. You have to have it. But if you say if condition block in next line, then there is new line here. And this new line is the limiter between condition and block. Therefore, this is perfectly okay. Colon is no longer supported. It used to be like this, but it is no longer that way. So colon is something that was replacement for then and do. Practically, then is a short word and do is even shorter than that. So there is no benefit of using colon to replace them. Therefore, colon is no longer used, but you are going to find it in literature. So new version of Ruby do not support this colon anymore. The role of end is very important because this shows that you have functional programming. In functional programming, each construct is an expression and returns a value that can be used. So keyword n is the statement terminator. It is used as a counterpart of the statement identifier. So if you have if statement, what is this if? If is the identifier of this statement. So language processor starts from the beginning of this line and hits this if, and then it says, aha, this is if statement. If you hit here loop, then it is loop statement. If you hit here something else, then it is something else. So the first word that you have here, if, unless, case, while, until, for, they identify what kind of statement is that. That's the first thing. If you have here no identifier, then it is arithmetic statement. For example, n equals 1. So this is arithmetic statement. But if you have if n equals 1, then this is identifier of if statement. So statement has identifier, then comes body of the statement and has the terminator at the end. So identifier is the left parenthesis, terminator is the right parenthesis of that expression. And terminator can only be one, it is end. So you have that, you have identifier and then body and then end at the end. So else end are parentheses, word delimiters. So this is the best possible way to write an if statement. If statement is written by having if, then, else, and. Then, else, and if are all of them word delimiters. This is left parenthesis, this is right parenthesis, and then is the delimiter between condition and block 1, and else is the delimiter between condition block 1 and block 2. You see that there is no need for curly braces that we have in other languages that have not a good taste. So this is the way how if statement should be written. If condition, then block 1, else block 2, and. And this is very short, very elegant, and returns a value. That is an expression. For if to end, it is an expression. It is going to return the value, and you can multiply this if statement by 3.14 if you want, and this is completely legitimate functional programming. Therefore, if statement that returns a value has here blocks of any complexity and words then else that are having separation between condition and block and block and block. This is how the thing should be. Very beautiful, elegant, general, and functional. There is nothing better than you can do than this. If else, if condition x is y, put string x equals y. There is no need for then because I put this in a new line. Else, put string x is not equal to y. Well, if you want to write all this in a single statement, you can use this then. Then you can say if condition, then this, else, this, and. But you can write it any way you want. It is going to work in all cases in the same way. This here is readable. And if you see here, if, else, and, okay. So this style of programming where you have indenting, where everything from if to end is here, shows the reason why it is good to put curly braces in languages that use curly braces one above the other. So if you have them one above the other, you see what is at the same priority level. If you put left curly brace somewhere here and right put here, then you don't know whose curly brace is this terminating curly brace. And of course, you have to go line by line to find where is that, which is inconvenient. If you put it one above the other, you know immediately the answer to that question, and you don't have to ask that. So what we have here is if then else. If else is exemplified here. If month is January, set m equals 1. If month is February, set m is 2. Else if month is December, put m is 12. In all other cases, you have an error, so you can put string error, or you can say m equals error, so you can have that the value that is returned is one of these strings, or you don't have m that is identified, but you have put string error. Whatever you prefer, you can do it that way. So that's what we have here. If else, we have that it can be written in two ways. If condition B1, else if C condition 2 B2, else if condition 3 B3, etc., else perform the end. So from if to end is this expression. It returns the last value. But more frequently, we write that in the single line. Then we have to use then. If condition then B1, else if condition B2, else if third condition B3, else the end. So this is a nice, easy, readable way of doing that. This else if can be indented a little bit, that you see this is the beginning of if and end of if. So this is two styles. I would indent this else if a little bit inside, not to put it this way. Name, if x is 1, then 1. If x is 2, then 2. If x is 3, then 3. If x is 4, then 4. Else many. What is this now? This is now expression. this 1 is expression, 2 is expression, 3, 4, and many. So depending on the value of x, which is 1, 2, 3, 4, we are going to return from this if statement one of these expressions, 1, 2, 3, 4, or many. Whatever comes out of this if statement is stored in name. So this name of variable is the name of variable that can have any data type. But when this statement is executed, then this name is going to become a string. And this string will be 1 or 2 or 3 or 4 or many. So you have this if statement that returns this value 1, 2, 3, 4, or many. And this is the way how if statement returns a value, which is very convenient for programming. You have possibility to select one of many things. There is also negated form of if statement. Negated form of if statement is unless. Unless x is y, put string x is not equal to y. So put string x is not equal to y in all cases, except if x is equal to y. So unless is x equal to y, put this string here. In all cases, that means x is equal to y, put string x equals to y. So unless is negated if. And this is convenient because frequently we want to have if not conditioned and do something, but you can use directly unless else. Unless statement is also possible to be applied as modifier. So you have put string, x is different from y. In all cases, unless x is equal to y. If x is equal to y, don't do that. So do that unless is x equals to y. In all cases, except when x is equal to y, display this. So unless is modifier of put statement. Put statement is here, and unless is giving permission or denying permission to do that. And so put string unless x is y. This is convenient. It is a little detail, but it is convenient to have it, both unless and unless as modifier. Unless, of course, can be used same as if. So you can say expression if, Boolean expression, and then if Boolean expression is satisfied, expression will be executed. Expression unless Boolean expression is going to be executed if the Boolean expression is false. So this is expression, this is exception where this shouldn't be done. So if this is false, expression will be executed. So they can be used as modifiers. Modifiers come at the end of expression. All this is support for procedural programming, plain vanilla procedural programming. There is nothing else but procedural programming, and of course, at the same time, also functional programming, because all of them are returning a value. Now, syntax of unless statement is unless Boolean expression, then body, else body. So you can have here body and you can have else. So unless else. Do not use colon because it is no longer supported. And if you don't write this as a single line, you can omit this then part. So this is syntax in EBNF. You have keyword, you have Boolean expression, you can omit this construct here if you want. You can also omit else body if you don't need it. You can have only one body, but you can have two bodies if you want. So body is usually written in the new line. In particular, it is always written in the new line if you have multiple statements here. If it is a single statement, put it in a single line. That's okay. Both if and unless return a value. This is functional programming. They have to return a value. So the value that is returned, the only logical value, is the last expression evaluated in whichever body is executed. So you have something that is inside if statement. You execute these statements, and the last thing that is executed is presumably the result that is computed in your computation. So this is returned to you in order that you can use it if you want as the beginning of another expression. So you can have a result that is returned from if that is used as the beginning of another expression or as something that is used in another expression. This is, of course, one of concept of functional programming. I want you at each moment to see how parallel is Scheme and Ruby in functional programming. That these are all concepts that you already know from functional programming that are now implemented in one language that, in addition to functional programming support, has also rich support for procedural programming and full support for object-oriented programming. Of course, functional programming in Scheme or Lisp or Ruby or Racket are something that is more than what is available in Ruby. For example, in Scheme, you can have those constructs where you have that you combine statement of statement, and you have that you can have definition of lambda expression inside lambda expression. So, and you can return from function another function. Well, this is not formally done in Ruby. So this is where Scheme has its own tricks that are not available in Ruby. But the fact that you can return from if statement a value is exactly the same as returning if state value from the if statement in Scheme. Ternary expression is done with dynamic objects. So I say string is, if x is y, then put string x equals y, otherwise return string x is not equal to y. So this str, which is the string variable, is going to be instantiated either with x equals y or with x is not equal to y. Now, this here is string and this here is string. And therefore, these are equal data types. In procedural languages, where you have static typing of string, you have to have that this object and this object has the same class belonging as this string, has to be same data type. In Ruby, that is not the case. You can have here heterogeneous expression. This can be a string, this can be a real number, or any two different objects. When you return from ternary expression an object, you assign this value to string. String doesn't have data type that is assumed before the assignment is performed. Therefore, you are going to have that string gets one of these values and data type at the moment of assignment. So if you have variable equals condition, object 1, object 2, these objects can be completely different, belong to different classes. So that's the point that we have here. Method precedence table. Well, you remember that some precedence tables are very modest. In the case of Scheme, we have that the precedence table is a little bigger, but in the case of Pascal, it has only 5 lines. Here, there are 20 lines. In the case of Fortran 77, 10 of them, and here is 20. This is a big language. It has a big table. So you have to expect that to understand that. So the first is reference of a component of array, then exponentiation, and then you have unary operators, not complement, plus and minus. All this unary stuff comes before binary operators, and binary operators go first with plus, minus, and modulo. Plus division, multiplication, division, and modulo. And then you have additions, plus and minus. And then after that, shift left, shift right. Binary, you take an integer, shift it left, shift it right. You have bitwise AND between integers, and you have bitwise exclusive OR. I don't know, are you familiar with cryptographic protection of objects? So cryptography is based on exclusive OR that is very frequently used between string of original text and string of random values, and then exclusive OR between them to protect them, to hide them from reading. So you have bitwise exclusive OR and OR for integers. Comparisons, less than, equal, etc. Then you have all these equalities and inequalities, and even pattern matching exists to a little bit do things that are similar to Prolog to some extent. Then you have AND OR that are at higher precedence level. That's not AND OR here. So this is not AND OR at lower priority. Ranges and ternary operator are rather low in precedence table. Then you have assignment or plus equal or times equal or all these combinations with equal, which is unary operator applied to objects. So you have n plus equals 1. So n is n plus 1. This means increment x or decrement x or divide x by something or something like that. There is also a possibility to recognize, define the question mark. Is recognizer same as scheme? Says, is this defined or not defined? If you have nil, nil is something that is an empty object, but you can have a variable that is not defined. And you can ask, is defined a variable? That means you came through one of those branches that define the variable. Otherwise, the symbol is undefined. If, unless, while, until are here, and begin, and as expected, the last priority level, because everything has to happen before we apply and begin. Case statement. A few words about case. Case statement has here when, condition, and then you have another condition and another condition if you want to have multiple of them. So when these conditions are satisfied, then perform body. When another sequence of conditions is satisfied, then perform body. Else, perform default body. So a series of conditions are evaluated, and then executing body of the first condition that is true. There is no break here. After body, there is no break. Break is assumed to be here. So name is case. So when you have x is 1, and this is condition 1, then return 1. When x is 2, then 2. When x is 3, 3. When x is 4, 4. Else, many. So this is case with conditions inside when condition. Then do this, put that inside this name. Here is an example. Leap year is one that is divisible by 400, or is divisible by 4 and not by 100. So if it is divisible by 400, then it is a leap year. So you have leap is case. When year modulo 400 is 0, then return true. So that is the case of the leap year. Now, if it is not divisible by 400 and is divisible by 100, then it is not a leap year. Return false. In all other cases, return true if year modulo 4 equals 0. So you see what I have here. There is no in this else then. I have here else, and this expression returns the value. And this value is true or false. So Here you have then true and then false. And here you have year 4 modulo, year modulo 2 equals 0. This returns true or false. So, for example, 2100 is a leap year. So please wait until that time and you will see that it is leap year. Now, syntax number 2, you have comparison, 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 and then. It is again case with selector variable, and you have these comparisons. Here we had a condition, and here we have comparison. So we have again first sequence of comparison, second, and last is else body. Again, do not use colon because it is no longer supported. Now, here is case selector example where we have war and we have case. So year here is a selector variable. When this selector variable belongs to this range 1914 to 1918, so when year belongs to this sequence, then return World War I. Then, in the case where year belongs to 1941 to 1945, then return World War II. In all other cases, return other wars. There are always wars somewhere. Therefore, it is safe to say other wars, except when the wars have name. In all other wars, they have no name, but there are always wars. So war is case end from here, and you can return one of these three things. Is this example? We have year is 1944, so end of Second World War. We have that leap is case when year is divisible by 400, return true. If it is divisible by 100, return false. Else have this what is returned here. So when you have this leap that applies to this year, then we can print year was a leap year, true or false. So it is going to print 1944 was a leap year, and this is true. And then we say, what kind of war was that? So war is case when year is from 1914 to 18, World War I, World War II, or other wars. And then you say the war was, and then plus war, because this is string, I can concatenate the war was World War I or other wars. So I have 1944 was a leap year, true, and the war was World War II. So this is the program, and this is its output. Now we have loops, and we will start with while loop, which is identical to while loop in all other languages. So while Boolean expression, do body end. You can omit this do if you want, don't use this colon. So while Boolean expression, perform body, and here is example. So you have x is 0.5, while x is less than or equal to 3. This vertical line is my cursor that remained when I took a screenshot here. So while x is less than or equal to 3, do display x and x squared, and then increment x by 0.5. So you have 0.5 and 0.25. Square of 2 is 4, square of 3 is 9. Now here is definition of array. Print elements of an array. Array is 1, 2, 3, 4. And then I say while I is less than 4, do put string array of I and increment array. You can omit this do if you dislike it. But I prefer to put this do because it tells you from do to end you have this operation that is performed. So you get 1, 2, 3, 4. And this is all what we have for today. Let me, in Thanksgiving spirit, tell you that there is an experiment in artificial intelligence that we are currently performing in a team where I am Daniel Tomašević and other people. And we would ask you, please go to this experiment that is posted in front of exams and give us answer. It takes 2 to 3 minutes to do that experiment, but it is going to be very important to see how people perform mental aggregation of heterogeneous things. So we are interested in partial conjunction function. We want to make a mathematical model of that. So please go there and help us collect this data. This is, of course, completely anonymous experiment, and it is not any intelligence test. It is simply the way to see how people aggregate things in their mind. And of course, if you want to make decision support systems, you have to make computer programs that behave same as human mind. So the first thing is obviously to see how human mind works with that. And therefore, I hope that you are going to give us 2 minutes of your time and provide answer to this experiment. So thank you. That is all for today. If there is some question, please go ahead. Any question or comment or something like that.